Operations Design. In this unit, we consider the design of operations. Since operations must be in alignment with the overall goals of the company, we start with the company mission, strategy, and business plan. If the focus of the company is responsiveness, the operation must be designed for speed. Once the operations strategy is set, we consider the different possible process designs to deliver our products and services. We will discuss the four most common designs: process, product, repetitive, and mass customization. Finally, we will look at various tools to facilitate process design, including flowcharts, value stream mapping, and service blueprinting. Compare the definitions of mission statement and strategy here. The mission statement may be compared with a destination, while the strategy consists of the highways and roads to get to that destination. Consider the mission statement of your current employer. Does it define a clear destination for the organization? The business plan defines the steps necessary for the business to be successful. Details include the processes, functions, organization, and resources required, along with the products and/or services that provide value to the customer. Both internal and external stakeholders are considered. The plan also includes a financial analysis that discusses the market share and profit associated with these products and services. The next step in the business process is the operations plan. We start with the mission statement, the destination, supported by the business strategy, the route, which is then enabled by the operations plan. This plan includes the actions necessary to deliver the goods and services provided to customers. Here we see the elements that must be in alignment for a strong strategic fit. External and internal stakeholders must share a common strategy and set of priorities. Without this alignment, conflict will occur and the business may not thrive. Recall the 10 decisions of operations management. Here we see a graphic displaying the link between these decisions and the differentiation strategy of a business. This strategy establishes those aspects of the business that make them unique or provide competitive advantage. Examples of companies that exhibit differing strategies are also shown here. What differentiation strategy does your company use? Note that many companies use a combination of these strategies. To support the alignment of the business with its operational strategy, the organizational structure must be appropriately defined. This structure includes the operational teams within the business, along with those of other partners within the supply chain. This includes product producers, service providers, distributors, retailers, and customers. Location decisions are typically a hierarchical decision, starting with the country, then the region, and finally the specific location. As with most major business decisions, the location chosen for a facility must be in alignment with the organization's strategy. For example, a low-cost strategy may be supported by locating near customers, low transportation cost, or by locating in areas with low labor costs. A responsive strategy is supported by locating near customers or near a major transportation hub. Quality is in the eye of the beholder. The definition of quality varies for different customers. Some are looking for conformance to specification, while others are looking for performance. The dimensions listed here include some but not all of the elements customers are looking for when selecting a product or service. What does quality mean to you? Processes transform resources into goods and services. Since the income of the business comes from customers minus the costs, we focus on meeting customer requirements and meeting cost goals. Process strategies typically affect efficiency, flexibility, cost, and quality. The best processes are aligned with the organization's strategy. This chart maps product or service volume and variety to process type. Low volume, high variety is associated with process focus, found in projects, job shops, restaurants, and hospitals, for example. High volume, low variety works best with a product focus, found in steel and glass production, commercial baked goods, and beer. A repetitive process is aligned with medium volume and medium variety, found in automobile and appliance production. Finally, mass customization is a fairly new concept, and while ideal, is difficult to achieve. This process addresses high volume, high variety found in computer manufacture and some software industries. Process mapping is a great management tool to describe, manage, and optimize a product or service process. Here's an example showing the flow of materials and components going into the assembly and crating of a motorcycle. For process focus, everything wraps around the process. Here are some of the key elements of a process focus. The high variety of products is supported by the flexibility of the process. Note the added complexity of planning and scheduling when a process focus is in place. An example of process focus will be found at the typical hospital. Medical procedures are typically customized for the patient, with many different starting points with a variety of outcomes. Timing is intermittent with multiple process routings. Repetitive focus takes advantage of assembly lines to reduce cost and produce repeatability. Assemblies often consist of standard parts and sub-assemblies. Modular assembly is common. This method is less flexible than process focus lines, but is more efficient. Harley-Davidson uses a repetitive process to build motorcycles. Inputs include raw materials and module inputs. The goal is to create a limited set of standardized modules that are assembled in many combinations to create many motorcycles. For a product focus, facilities are organized by product with a high volume but low variety of products. Due to the use of continuous production lines, the process is efficient with low variable cost but high fixed cost. Each production line is a major investment. Frito-Lay uses a product focus to mass produce high volume snacks in a continuous process. A limited number of inputs create a finite variety of products differentiated by mix and packaging size. Mass customization tries to create the best of both worlds, using high volume techniques while producing a unique customer experience. Often this customization is completed by using standard hardware devices with a wide variety of loaded software. Dell Computer uses mass customization to create custom computers on demand. Customers select among a list of standard parts, modules, and software loads. The result is a high volume, high variety output producing custom PCs and notebooks. This table shows the impact of mass customization techniques increasing the volume of customer choices for a variety of product types. Now that we've considered the four major process types, we look at various tools used to design your process. These tools include crossover charts, flow charts, process mapping, value stream mapping, process charts, and service blueprinting. For the crossover chart, we look at multiple options and evaluate the fixed and variable costs. The goal is to find the points where the total cost points to one option versus another as being most cost effective based on product volume. For the crossover chart, we look at multiple options and evaluate the fixed and variable cost. The goal is to find the points where the total cost points to one option versus another as being most cost effective based on product volume. For the data given in the previous slide, we find the volume where the total cost is identical. Mathematically, we calculate the volume V1 where software A and B have the same total cost. We see that the crossover point from software A to software B is at a volume of 2,857 reports. Similarly, the crossover point comparing software B to software C is at 6,666 reports. This slice graphic represents the previous data showing the three software products and their respective fixed and variable cost. The crossover points are identified where one total cost line crosses another. Thus, software A, the green line, is the most cost-effective at a volume of up to 2,857 units, while software B, the yellow line, is best for volumes from 2,857 to 6,666 units. Finally, software C, the red line, is the best choice for volumes above 6,666 units. The next series of slides review tools used for process analysis and design. We will discuss the movement of materials through flow diagrams or flow charts, and then use time function mapping to see the progress of the process over time. This is a typical process flow diagram for the assembly of a motorcycle. We start with the first process, frame tube bending, in the upper left corner. We move to the right with subsequent process steps until we crate the completed motorcycle at the lower right. Note that components arrive at the assembly line on a just-in-time basis from various work cells. This highly effective flow turns 450 parts and sub-assemblies into a completed motorcycle in 3 hours. This time function process map shows the steps associated with a customer order fulfillment process as originally defined. Not only do we follow the process steps, but we see that the steps are spread out over time. The time scale is on the horizontal scale, while the vertical lists the various entities responsible for each step. Each horizontal slice holds the steps tied to the entities on the left. These are often referred to as swim lanes, since they are similar in appearance to the lanes roped off with a lap pool. For example, the warehouse is responsible for 3 different weight steps. This process map is useful for understanding cycle time along with the transportation complexity of the process. Every time the product changes swim lanes, there is an opportunity for lost communication. This new map shows the revised process map once the process has been improved. Graphically, the flow is simpler. 2 wait steps and 1 move step have been eliminated. Plus, the 2 value-added steps of print and extrude have been combined to a single location. The result is a reduction in the number of swim lanes crossed from 10 to 6, and a total cycle time reduction from 52 days to 6 days. Note that this is achieved without reducing the time available for the value-added processes. Quite an improvement. Value stream mapping identifies the steps of the process that add value along the entire supply chain, from initial suppliers through the distribution process to the final customers. Value stream mapping is another method for understanding a complex process and exposing opportunities for improvement. In addition to material flows, communication links for forecasts and orders are also displayed. Note the 4 value-added processes listed near the bottom. In summary, only 140 seconds of value-added time is added over a duration of 26 days. A service blueprint is a specialized process map used to analyze service processes. The blueprint focuses on the customer and considers 3 levels of interaction. Potential failure points along with sales opportunities are identified. This service blueprint displays the processes found at Speedy Lube. The first level represents the customer. The second, middle level, depicts the interaction with the customer, while the third level displays process steps away from the customer. Using our standard mapping methodology, ovals represent process steps, while diamonds represent decision points. The process moves forward from each decision point based on the decision made. The red circles represent failure points or opportunities of increased sales. For example, the first red circle in the upper left is a risk, as there may be a miscommunication between the service technician and the customer. At the same time, there is also an opportunity to upsell additional services and products. Key points to remember. When establishing a new business operation, we consider the design of operations. Since operations must be in alignment with the overall goals of the company, we start with the company mission, strategy, and business plan. The most common operations strategies are cost, responsiveness, and differentiation. if the focus of the company is on responsiveness. The operation must be designed for speed. Once the operation strategy is set, the structure of the operation must be in alignment. Next, we consider the different possible process designs to deliver our products and services. For low volume, high variety products, process focus is selected. For high volume, low variety products, product focus is chosen. Repetitive processes fill in between, while mass customization is used for high volume, high variety products. Finally, we look at various tools to facilitate process design. Crossover charts are similar to break-even analysis and display the best options given a range of variables. Flow diagrams show the process steps, decisions made, and flow of product. Time function mapping takes the process diagram and adds the various times needed for each step. Value stream mapping takes the process flow and distinguishes between value-added and non-value-added steps, including the time required for each. Finally, service blueprinting is a flow diagram customized for the service process with a focus on customer interaction.